It consists of only one type of atom.
Well done, Quentin. So it consists of only one type of atom. Good. Right. Chloe says it's part of something abstract. Chloe, where did you get that answer from? Because it sounds very googly, like you got it from Google. I want to know. Okay, moving on. Classify the following atoms or molecules and then as elements or compounds. Write your answers next to the question number. So first of all, none of these are atoms. They're not just atoms, right? They all are molecules. Okay, and I know some of you got like all three correct, but none of you got all four correct, and I'll tell you why. So this is a compound, right? Because why is it a compound? There are two or more different types of atoms bonded together, right? This is their molecules here. Oh, I see, Chloe. All right, we'll talk about it later, right? Yeah, and then guys, we have elements and compounds in the last one. Why do we have elements? Because can you see that there are two circles with the same color that are bonded together? So those could be diatomic elements, all right? So it could be oxygen or hydrogen or chlorine or bromine or iodine or fluorine, right? And those are all elements, even though they exist as diatomic molecules. Okay, and then these little Mickey Mouse figures, those are compounds. Moving on. What are the three subatomic particles of an atom? Guys, if you've done badly in this test, I am not allowing you to rewrite. But if I feel that you need CSI, I will be contacting your parents. All right. So if you failed because you just never study enough, then it doesn't mean you need help or support. It means that you just need to work harder, right? But if you've done badly because you genuinely need help throughout this term, then you know, let's chat on WhatsApp and we can organize times when we can talk. So Sarah says neutrons, protons, and electrons. Well done, Jason, as well. So I'm trying to copy and paste what you guys are seeing onto my chat. Okay. All right. Give the atomic number of the following atoms by referring to the periodic table. Remember, atomic number what does atomic number tell me, guys? Let's look at the periodic table. So does no one know what an atomic number represents? Can anyone tell me? No one? Sarah says the small number that weighs the object. In a way, you're right, Sarah, because the atomic number tells us the number of protons and electrons. But the bigger number, right, the one at the bottom here, tells us what the weight of the atom, right? So what the small number or the atomic number tells me, I see Muawiyah is just entering now. Hello, Muawiyah. Hello? Hi, Muawiyah.
I left. Mistake.
Why are you late to my class?
No, I mistakenly left. I mistakenly left.
Okay. All right.
Mistake.
Okay. All right. So the smaller number is the atomic number, and it tells me how many protons and how many electrons there are in an atom. So if we look at beryllium over here, right, it says 4 The 4 tells me that there are 4 protons and 4 electrons in the atom, in one atom. Okay. Okay, so guys, the atomic number for lithium was 3, and the atomic number for magnesium was 12. Right, and yeah, some people had an issue here, right? I told you guys to identify the following atoms. So if you knew what atomic number was, you'd be able to really ace this, right? So if we see here, if we count how many protons there are, there's 1, 2, 3, 4, and how many electrons? There's also 1, 2, 3, 4. So you use your periodic table to answer this question. And we look at beryllium again. Beryllium is the 4th element of the periodic table, which means that it has 4 protons and 4 electrons. So that atom in particular is beryllium. All right, who got this one right? Did anyone get it right? Good, Ethan. Well done. All right. Okay, so moving on to 1.6.2, we have 1, 2, 3, 4, 5, 6, 7. Yeah, we have 7 protons and 7 electrons. Let's see which element that is. Okay, so from here I can see that it's nitrogen. Nitrogen is the 7th element on the periodic table, and the 7 also represents 7 protons and 7 electrons. Okay, so I'm just gonna write here nitrogen. Okay, then for this one here, I think it was Marcus who drew me a table. Quentin or Marcus, one of the two. Yeah, so you drew me a table, but the rest of you did not draw me a table for this, right? Guys, whenever I say tabulate, I'm talking about writing your answers in a table and comparing the differences. So let's give an example. So first of all, you need to give your table a heading, always, right? You get a mark for that. So what would you call the heading? Table showing differences between pure and impure substances, right? And then for one column, you call it pure substance, and the other column you call it impure substances. So then I know what are you talking about each time you give a characteristic, right? You can even, now that you have Microsoft Word, you can really make it pretty. You can use colors, okay? All right, so the first difference between a pure and impure substance, can you tell me in the chat? Not gonna number it, rather not. Just bullet it. Think of examples of pure and impure substances. No one? Okay, so can be separated by physical means. Is that pure or impure? Okay, so Sarah says a pure substance. Do you all agree with Sarah that a pure substance can be separated by physical means?
Yes, ma'am.
Okay, so guys, it's actually incorrect. An impure substance can be separated by physical means. But thank you, Sarah, for giving us the text for that answer. All right, and then Chloe says a pure substance has a constant chemical composition. I like that. I'm going to put it here for the second one. And for pure substances, they cannot be separated by physical means, right? Cannot be separated by physical means, only chemically. And how are they separated chemically? Well, through processes like electrolysis and passing heat, right, through substances. So if a pure substance has a constant chemical composition, that's like in every single compound of water, you always have two hydrogens or one? Yeah, 2 hydrogen atoms and 1 oxygen atom. All right, but in an impure substance, there's no constant composition, right? No fixed ratio between elements. That means that, for example, you have an impure substance like air or the atmosphere. There's no fixed amount of like substances in the air, okay? We have like carbon, we have carbon dioxide and oxygen and water, right? But we don't always necessarily have all of that at once in the same place. Okay, let's give it one more differentiation. Can you guys think of an example? What is an example of a pure substance and what is an example of impure substance? Just gonna close my video for a second. For some reason, my legs are really aching today. Okay, so I'm gonna give you guys the heads up here. Sarah says an impure substance is salt. Salt. I would say salt water, right? Salt is a pure substance. When you take salt and you add it to water, sugar, water, all right, that's an impure substance. But salt on its own and sugar on their own, those are both pure substances, okay? Because they're made of a particular amount of elements in each and every compound, okay? But examples of pure substances, that's like gold and silver and oxygen alone, pure salt, pure sugar, absolutely. All right, and I just want to give one more thing. Pure substances are elements and compounds. Impure substances are a mixture, remember mixture? Mixtures of elements and compounds, right? So if I have elements and compounds together, like for example, this substance here, this is an impure substance. Why? Because it has a combination of elements and compounds. But this substance over here, this is a pure substance because can you see it's only made out of one compound, right? Moving on. Give the chemical formulas for only 5 diatomic molecules. So have no fear if I spell beer. It's H2. Come on, guys. What does N stand for? What does O stand for? What does C stand for? And I want answers from those who are quiet. Muawiyah, I haven't heard anything from you. Watupa, you also?
Nitrogen.
Nitrogen. And remember, I'm asking for the chemical formulas, right? Not the words. What does F stand for?
Fluorine.
Good. Well done, Marcus. Then O and C. What does CO stand for? Chloe says C2. You're close, Chloe, but C is carbon. And that's the C in a diatomic molecule
Carbon.
is not carbon. It's something with a C.
Chlorine.
Well done, Marcus. Chlorine. Ice cold beer. What does beer stand for?
Ginger beer.
In symbols, Ma'awiyah. Like oxygen, nitrogen, hydrogen, like that.
E2. E2.
Br2. Okay, don't get confused between.
But I was close. I was close.
You are
I was close.
Yeah. All right, moving on to ratios. So guys, I know that you guys had various ways of doing this. Now, let's establish one way in which we are going to be writing ratios. So in mathematics, you guys write ratios by writing numbers and separate them by colons, right? We're going to do the same in science because it's basically maths and science are related, right? So in this compound here, we have 2 atoms of calcium and 2 atoms of chlorine, and Chloe has said that you will represent it as 2:2. Well done, Chloe. But this one was a little bit trickier because it has 3 elements. It has hydrogen, it has sulfur, and it has oxygen. How do we know that there are 3 elements? Firstly, because can you see how they all are caps lock? They all are capital letters. If I have, I would know if I have like more than 2 letters together, if it's one substance or 2. If those substances are, one is a capital and the other one is a lowercase, that would only be 1 element. Okay, and then Chloe says the second one is 2:1. 3. Well done, Chloe. Excellent. Does this make sense to everybody? Can you all see that there are 2 hydrogen, 1 sulfur, and 3 oxygen atoms? Good.
Yeah.
Very nice. Wonderful, guys. Okay, and lastly, we have this molecule here, and I try to get the most complicated molecule online, and this is what I got. Okay, so how many atoms makes up this molecule? Now, I know that some of you wrote 23, but help me count again because I counted 24. So I just count together quickly. Yeah, I'm still counting 24. So if you've written 24, then it is correct, right? Good. And then it says how many different atoms make up this molecule. And for those of you who double check this answer, you would have written 4. Yes. Okay. All right. I know that who got in the 60s for this paper? I think it was Ethan. Was it you, Ethan?
I think so, ma'am.
Okay, I think it was you, and very well done, hey. Who I think
Thank
it was
you.
Marcus as well, or Sarah, one of the 2, or maybe both. Yeah, but you guys never done so well in this paper as all in all. All right, some of you got below 40%, and that is concerning. Okay, that means that either you never spend enough time studying through the notes I gave you, or you need a little bit of extra attention. Okay, so you need to check.
Ma'am?
Yes.
Are we going to rewrite this test?
I'll have to see what your marks are. Okay, you guys will only get the opportunity to rewrite if you do CSI with me. Okay, so if you're doing CSI,
For me, I got 35.
yeah, then
Yes, sir.
probably. Okay,
Is
so
that good, ma'am?
it's actually not a good mark for this paper. No, you need to score at least 50 and over for your papers. Okay, guys.
Please let me rewrite this test, ma'am.
We'll talk about it on WhatsApp. Okay. All right, guys. Have a wonderful day. I'll see you tomorrow. Bye.
Okay, ma'am. Bye.
Bye.
Bye.